但今天还好搬了个风扇了。
现在我们已经开始了。好的，行，我们已经入镜了，对不对？对。没关系，我觉得这边。到05分的时候，我们会给你 OK 一个手势。行。其实您还有1分钟的时候，我们立刻就可以坐在这边，我们就随时开始。
你好，你可以说一声，我们就是说，可以就是再等待一下。
哦，好的，好的。
到05分正式开始。
有人进来了吗？有人进来了吗？好的，哦。Okay, so our live broadcast will start after 4 minutes. So let's wait for our audience to come in the live broadcast room, and we will prepare some work before the instruction.这边是有人进来了是吧？
就是我们可以欢迎他们。然后说跟你
Okay, hello friend, welcome to our live show. We will start after 3 minutes.我在手机上看，对。
这个可以用官方号去回。
哦，对，官方的应该是可以的。是的，下次其实可以在这个地方放一个5分钟的倒计时，不知道能不能搞，就是那种插件一样的，就是比如说直播正式开始倒计时，对吧？这样就不用提醒了，对。我这个先不用拿，反正我等会儿应该要退出来的。
操作嘛，操作是属于操作。
嗯。
我认为，
哎，也可以就架在这里，对。Okay, our live broadcast will start in 1 minute. So let's welcome our audience to come in. Okay. Hello, this is Nico from Changzhou Meditech.
This is Steven. I'm the engineer from Changzhou MedTech.
Today we will introduce 2 new products from our company. So let's not waste the time and start the introduction now. Okay, the first is the beveled cannulated screw. From the appearance of the cannulated screw, we offer two designs of beveled cannulated screws, and they are the Hubbard type with a smooth rod in the middle and the cannulated screw type with 4 threads. The beveled Hubbard screws are available in 2 diameters, 2.5 mm and 3.5 mm. 2.5 mm length from 12 to 30, 2 mm as a gap. 3.5 mm length from 16 to 46, 2 mm as a gap. And the 4-threaded cannulated screws are available in 3 diameters, 3.0, 3.5, and 4.0. 3.0 mm length from 14 to 32, 2 mm as a gap. 3.5 mm length from 16 to 50, 2 mm as a gap. 4.0 mm length from 20 to 60, 2 mm as a gap. Okay, now let's start the introduction of the features of these 2 products. First, it's the Hubbard cannulated screw, which has a cutting edge on the head, which is designed for self-drilling. There is also an incision on the back side of the front half of the thread to facilitate the twisting out of the cannulated screw. There is also an incision on the rear thread to facilitate the inserting of the second part. There is a 45-degree bevel at the end of the screw body. The middle rod is smooth and the 2 ends are threaded. Okay, the next is the 4-threaded cannulated screw, with the entire screw body threaded. This screw can provide a more stable friction. The cutting edge of the head is also designed for self-drilling. There is a cutting edge at the second part at the rear end to facilitate the overall inserting of the screw body. Both of these beveled screws adopt a variable pitch design. The pitch of the front and the back thread of the Hubbard screw are different. The purpose is to have a compression effect on the fracture part. The thread pitch of the fully threaded cannulated screw continuously decreases at the rear section, achieving continuous pressure during the insertion process. The tail of a conventional cannulated screw is flat. So what is the significance of a cannulated screw with a 45-degree bevel at the tail? During surgery, in order to fix the fracture part, the screw is often inserted into the bone fracture at a larger angle to fix the bone. When a conventional flat-headed cannulated screw is inserted in at a large bevel angle, if the inserting depth is not enough, the cannulated screw cannot be effectively buried in the bone surface. If the screw head is completely inserted into the bone surface, the tail of the screw will be buried after the bone grows. It will be difficult to remove the screw in the future. Okay, let's demonstrate the surgical operation of the beveled cannulated screw. The tools required for this operation are the same as those for conventional headless cannulated screws. Prepare some necessary basic tools, including the bone curette, reduction forceps, etc. The instrument set includes guide wires, guiders, cannulated drill bits, depth gauges, cannulated screwdrivers, handles, etc. Okay, in order to save time, a fractured bone is prepared in advance. Simulate the fracture line position. Now the fracture site needs to be fixed with a beveled cannulated screw. We choose the 3.5 millimeter Hubbard type beveled screw. 那我就开始了。Okay, first, along the vertical direction of the fracture line, with the help of the guider, insert the guide wire. Use a cannulated drill bit to establish a screw path for the cannulated screw along the guide wire. Okay, welcome our audience to come in the live show. Okay, after measuring the depth, select a cannulated screw of appropriate length and insert it into the cannulated screw along the guide wire with the cannulated screwdriver. Before inserting over the fracture line, we can see there is an obvious gap in the fracture line. After inserting over the fracture line, we see that the gap becomes significantly smaller, which means that the inserting of the cannulated screw has a significant pressure effect on the fracture line. From the tail section, the tail of the beveled cannulated screw body and the bone surface with a very good match, and the tail of the screw and the bone surface are relatively level. The tail of the screw will not irritate the soft tissue, nor be buried deep in the bone surface. The surgical procedure for the 4-threaded cannulated screw is the same as that for the Hubbard screw. There is no significant difference in clinical use, and the doctors can choose according to their preference. Okay, above is the operation introduction of our beveled cannulated screw system. Okay, let's wait for some minutes and we will start the second product. Okay, now let's introduce the second product, which is also the new product from our company. It's the Fibular Intramedullary nail system. It is mainly used for distal fibular fractures. First, let's introduce the implant. The nails are divided into two diameters, 3 and 4 millimeters. There are three lengths provided, which is 130 millimeter, 180 millimeter, and 230 millimeter. The nails also have left and right side, a total of 12 specifications. The nails of different diameters are divided into two colors. 3 millimeter is in gold and 4 millimeter is in green. The nail end cap is available in two specifications, 0 millimeter and 5 millimeter. The nail pre-installed end cap is 0 millimeter. Next is the 2.7 millimeter locking screw, specially designed for this system. After it is inserted in, its head will sink into the bone surface to reduce irritation to soft tissue. The longer screw is a 3.5 millimeter cortical screw. It is used to connect the tibia and fibula. There is also a sterilized packaged tibiofibular joint bottom that provides a new solution for the tibiofibular connection. Okay, next are the instruments. Pointed reduction forceps can be used to fix bone fragments during surgery. 1.6 millimeter short guide wires, one smooth rolled guide wire and one threaded guide wire. 2.4 millimeter guide wire with hole used to guide the lead wire of the tibiofibular joint bottom through the tibia and fibula. 1.6 millimeter long guide wire. It's mainly used to drive into the medullary cavity and establish the medullary cavity channel of the nail. Nail depth gauge used with long guide wire. Protective sleeve. The guide wire driver sleeve can realize the insertion of the guide wire. Two drill sleeves, 3.2 millimeter and 4.2 millimeter. By changing different sleeves, drill bits of different diameters can be driven in. Two drill bits with different diameters, 3.2 millimeter and 4.2 millimeter, corresponding to two nail diameters. A medullary clavicle AWL, or, and a medullary reamer with limited depth. These two instruments can be used with expand the medullary cavity at the distal end of the fibula. Next comes the reduction shaft and a reduction sleeve. Aiming target device, 瞄准架. Connecting bolt to fix the nail and the aiming target device. Wrench. Inserter and a hammer. 2.0 drill bits are used to open the holes for the 2.7 locking screws. Two 3-stage sleeves for 2.7 locking screw implantation. Includes torque, drill sleeve, and a protection sleeve. Straight depth gauge used for measuring the depth of 2.7 millimeter locking screw. Two 2.5 drill bits are used to open the holes of 3.5 millimeter cortical screws. A 3-stage sleeve for 3.5 cortical screw placement. Includes torque, drill sleeve, and protection sleeve. a 3.5 tap, a depth gauge with a hook on the head, used for measuring 3.5 cortical screw, 2 3.7 drill bits for creating channels for tibiofibular joint bottom, a 3-stage sleeve for a 3.7 drill bit, a T-shaped quick coupling handle, 2 T15 screwdrivers, 1 quick coupling type and 1 with silicone handle. The self-holding design of the screwdriver can hold the locking screws and the end caps. An L-shaped hexagonal wrench for adjusting the drill depth stop. Next is a nail extractor, which is used in conjunction with a slide hammer after inserting it in when removing the nail. A guide wire holder, mainly used to remove the guide wire. Okay, next we will prepare for the simulation of the fibular intramedullary nail surgery. 开始操作。Okay. The first step of the operation is to reset the bone fragments. Using pointed reduction forceps or other instruments to reset the fracture ends. Confirm that the reduction is accurate in the anter-posterior and lateral positions of the C-arm machine. Next, determine the insertion point. 确定进钉点。And then let's insert the guide wire. Place the proximal protective sleeve at the insertion point and place the guide wire drill sleeve. Insert a 1.6 mm diameter guide wire. Pass through the fracture line until the guide wire is in the center of the medullary cavity. And use anter-posterior and lateral fluoroscopy to ensure that the guide wire is in the best position. Insert the nail depth gauge along the guide wire and press it against the bone surface. The depth of the guide wire insertion can be identified from the reading of depth gauge. The length of the nail must be less than the depth of the guide wire insertion. Okay, and next is the proximal medullary expansion. Remove the guide wire drill sleeve. 近端扩髓 And drill along the guide wire through the protective sleeve into the proximal hollow medullary expansion drill until the limit position. Next is the distal medullary expansion. Remove the proximal hollow reamer. Place the drill sleeve and drill into the hollow reamer along the guide wire through the drill sleeve until it reaches the limit. The 3 millimeter nail uses a 3.2 millimeter drill sleeve and a 3.2 millimeter hollow reamer. The 4 millimeter nail uses a 4.2 millimeter drill sleeve and a 4.2 millimeter hollow reamer. Do not withdraw the guide wire after distal reaming is complete. In this simulation, we plan to implant a 3 millimeter nail. Therefore, we use a 3.2 millimeter sleeve and a 3.2 millimeter cannulated drill bit. Okay. Yeah. Next, it's the insertion of the reduction shaft. Place the reduction sleeve on the reduction shaft. Insert the reduction sleeve and the reduction rod along the guide wire. And remove the reduction sleeve and guide wire after inserting to the appropriate depths. And then we will insert the nail. Select the nail of appropriate specification. Use the connecting bolt to connect it with the aiming target device. And ensure that the black line at the tail of the nail is aligned with the black line of the aiming target device. Use a wrench to tighten the connecting bolt to firmly connect the aiming target device with the nail. Insert the nail to the appropriate position along the reduction shaft. If it is difficult to insert, we can connect the driver to the bottom of the aiming target device and tap it gently with a hammer to make the nail pass smoothly through the medullary cavity. Okay, so next is locate the nail implantation depth. Insert the 1.6 millimeter guide wire into the nail implantation depth position hole and perform fluoroscopy to determine the nail implantation depth.静钉了是不是？要静钉了吧？好的。Okay, now we will locate the tibiofibular screw fixation position. Insert the 1.6 millimeter guide wire into the screw position hole and perform fluoroscopy to determine the screw fixation position. Insert the 2.7 millimeter locking screw. Put the torque drill sleeve and the protective sleeve into the corresponding distal transverse locking screw hole on the aiming target device. Make a 1 to 1.5 centimeter skin incision at the skin position indicated by the guide wire and remove the torque. Select a 2.0 millimeter drill bit to drill the hole. Remove the drill bit and the drill sleeve. Select a straight depth gauge to measure the depth. Use a T15 screwdriver to insert the transverse locking screw of the appropriate length until the screwdriver mark line is level with the sleeve. 已经介绍了。And then remove the screwdriver and the protective sleeve.
接下来我们准备植入第二颗钉。
There are totally 3 screws we will insert, and now it's the second. Now it's the last one. The fixation of the 3 distal transverse locking screws is completed in sequence. Okay, the first solution is finished, and please wait for a few minutes. And 你不要拆吗？不拆。OK， 好的。Okay, and next, let's prepare for syndesmotic fiction. There are position at the skin position indicated by the torque. Remove the 2.5 core rod. Select a 2.5 mm drill bit to drill the required screw. 钻孔完成了，是不是？ After drilling is finished, use a depth gauge with hook to complete the depth measurement. Use 3.5 mm tap to tap. Remove the drill bit and drill sleeve. Select a hook type depth gauge for depth measurement. Use a T15 screwdriver to insert a screw of appropriate length until the screwdriver mark line is level with the sleeve. Remove the screwdriver and the protective device.准备还上钉。And the screwdrivers can hold the screws.时间吗？Okay, the option 1 is finished. And now we will prepare for the option 2. 技工，你好了跟我讲啊。啊？你好了跟我讲。行，我现在拆掉，准备option 2。就是先拆除了，你现在可以说拆除了这句话。Remove the screwdriver and the protective sleeve. Okay, now it's the option 2. It's the Tibiofibular joint button fixation. For simulation, the combined screws of option 1 we already removed. Okay, now establish the transverse tibiofibular tunnel. Put the 3.7 millimeter torque, 3.7 millimeter drill sleeve, and 8.0 millimeter protective sleeve into the corresponding screw hole on the aiming target device. Make a 2 to 4 centimeter skin incision at the skin position indicated by the guide cone. Remove the torque. Select the 3.7 millimeter drill bit to drill through the medial cortex of the tibia. Once the transverse tibiofibular channel is established, the aiming target device can be removed. Unpack the tibiofibular button. Insert the blue wire into the 2.4 Howard guide wire. And pass the blue wire from one side of the fibula to the inner side of tibia through the transverse channel. 可以直接穿对。After the blue wire passes through the transverse channel smoothly, use the remaining tools to pull the flat titanium plate to the inner side of the tibia. Straighten the flat titanium plate so that it is stuck on the outer side of the tibia bone surface. 可以，然后准备收紧了是吗？好的。The two wire harnesses of the round titanium plate on the fibular side are tightened steadily to fix the tibia and fibula under reasonable tension.
也保证这你下面的线一直是张紧的，稍微远离就行。
The tibiofibular joint bottom provided by our company do not need to be knotted. After reaching the ideal position, use scissors to trim the wire harnesses at both ends.
自入伪冒了。
Finally, according to the nail depths, use a T15 screwdriver to implant an end cap of appropriate length to complete the operation. If need to remove the nail, remove the end cap, transverse locking screw and the 3.5 screw in turn. Insert the nail extractor into the tail of the nail and use a hammer to gently knock back and remove the nail. The above are the entire surgical steps. 然后我还要再到那边去就是结束语对吧？ 还是要坐下的吧？
坐下来。
就这样。
把画面调一下，调到我们两人附近好了。蹲下来吧，坐下来吧。说的感谢话。
好的。Okay, that's all for today's live broadcast, and these two are both the new products from our company. If you are interested in them, please send us your inquiry. Okay, so Stephen, let's say goodbye to our audience. Bye bye. 好了。OK。